Hello and welcome once again for our fourth video of microeconomics. I'm Balazaude and I'm excited to guide you through another enriching sessions in microeconomics, a subject that plays vital role in understanding national and global economic dynamics. First of all, uh, as in the previous, we have discussed about GDP, the definition of GDP, components of GDP, and how can we measure GDP. That is, as we said, we can measure GDP in three ways. That is, expenditure approach, income approach, and the production approach. However, their value at the end is equal because, as we said, expenditure for one party is income for other parties. And because of that, the value of GDP in all ways of calculation is the same. Today, we will see how can we calculate GDP growth. GDP growth. We can calculate GDP growth in two ways, that is discrete versus continuous GDP growth rate. As we know from mathematics as well as from statistics, when we said discrete, we measure or calculate growth at a constant time or at a fixed time, while calculating GDP growth in continuous is as continuous time. At any movement, we can calculate GDP growth with continuous. When we compare the value of discrete and the continuous GDP growth rate, they are different, or their value is different, even though their annual rates or growth rate is the same. Because of this, continuous GDP growth is all the time greater than discrete value of GDP growth, even though the rate is the same. That's why on this graph, a GDP growth for calculated using continuous, which is shown by yellow line, is greater than that of blue line. Because of this, there is a difference. Let us see what is discrete in the continuous GDP growth rates. The types of method for GDP growth calculations, as we said, is discrete. That means the quantity increases at a specific time interval, usually once per unit time. Example, once per year, once per month, or per day. And the continuous calculations growth rates is quantity increase constantly at every moment in time. This at every time moment in time. For example, for a discrete, interest rate is calculated annually. That is calculated, growth of it is calculated through discretes. Let us see the example. Through the example, we can understand. Also, you have to remember a graph that we show before. Suppose GDP grows at 4% per year. From this, by having this information, what is its levels after 5 years? What is the cumulative percentage growth over 5 years? Let us see the level and the cumulative percentage growth for 5 years. Example 1, assume our GDP is growing in jumps. That means discretely we use the formula as follows. GDP of time t plus 5, that means the next 5 years, is equal to GDP at time t in the bracket 1 plus r, that is growth rate, r or 0.04, the power of 5, that is n or maturity time, and the GDP time t times 1.04 the power of or exponent of 5, which is equal to 1.2166 times GDP at time t. The cumulative percentage growth rate is then 1 plus growth rates or 0.04 the power of 5 minus 1 to get the cumulative percentage growth. It is 21.66% or 0.2166. This is the cumulative percentage growth using a discrete. Example 2, if the discrete gross GDP is growing at 5 annually, how long does it take to double itself? How long it take to double GDP? Since GDP doubles in X years, we don't know that, so we have to take variable X. Then GDP at time t plus X is equal to 2 times, that is double, GDP at time t, which means we need to solve 2 is equal to 1.05 the power of x. X is a time or doubling time. We are going to solve variable x. To solve this equation, we log both sides of its changing. To get a time, we have to use logarithm. Log 2 is equal to log 1.05 the power of x is equal to x times log of 1.05 is equal to 0.301. Both sides, log 2 is equal to 0.21893. X is equal to log of 2 over log of 1.0.05. It becomes 14.21. The GDP of an economy growing 5% annually will double in little over 40 years. To double itself, it needs 40 years. We are calculating a time. We are calculating a time. When we want to calculate the time, we have to make a log. Method 2. If GDP grows continuously, we are going to compare continuous GDP growth and discrete GDP growth. Then GDP at time t plus 5, the next 5 years, is equal to GDP at time t is the power of, that is epsilon, the power of, which represents 2.218, as you know before, is the power of 0.04 times 5, which is equal to 1.221 4 times GDP. The cumulative factor in method 2 is 1.214 compared to 1.216 in method 1 or a discrete, which is what we expected. That means cumulative growth is always higher in the continuous compared to the discrete case. We have seen this by graph first on our first page. On our graph, as we said, GDP growth of continuous, which we have shown by yellow line, is greater than that of blue line or that of discrete values. This is because GDP continuous means that is compounded growth, not at a specific time. It is calculated at any movement. That's why somewhat is greater than it. If the continuous growth GDP is growing at 5% annually, how long does it take to double? In the previous way I've said, to make double, it takes around 40 years, 40 point some to some years or months. To make it double, 2 times the GDP at time t is equal to GDP t is the power of 0.05 times x. This is the value of it. Now it also a time or a years equal to 2 is equal to is the power of 0.05 when we make its division. Taking the natural log of both sides of this equation, one obtains ln 2 natural logarithm 2 is equal to ln e to the power of 0.05 times x is equal to 0.05x. Since x is equal to ln 2 over 0.05, when we divide it 0.05 for ln e to the power of 0.05, ln for ln 2, we get 13.8629. GDP will double in less than 40 years because it is very fast. The frequency is fast and are continuous and faster compared to the case of the discrete growth. In discrete growth, we need around 40 years and some months. Under the continuous, we need to double our GDP in 5 years and 13 years. At least it is greater than in 1 year or something like that. Example, GDP measured in a country in 2002 rise from 256,501 million in 1948 to 9,888 9,008,000 and 338 million in 2002. What was the average annual growth rate? The average annual growth rate. Method 1, discrete growth. Let us see by discrete growth. GDP of 2002 equal to GDP of 1948 or 1948 1.1 plus r the power of 54, which is equal to GDP of 2020 over GDP of 1948 equal to 1 plus r to the power of 50, that is n. Plugging in the value of GDP levels in 1948 and 2002, we obtain 3.853. This 54 is the difference between 2002 or 2002 and 1948. That is number of years or n. Plugging in this value for GDP levels in 1948-2002, we obtain 3.853 equal to 1 point r to the power of 54. Taking a natural log of the both sides of this equation, ln 3.853 equal to 1.348852 equal to 54 times ln of 1 plus r. Then ln of 1 plus r is equal to 1.3485 over 54. We make it division and then it becomes 0.024974. Then 1.1 plus r is equal to e to the power of 0.024, that is what we get above equal to 1.025. Then R is equal to 0.025 or 2.5. This is how we can calculate discrete using discrete method to continuous growth. GDP of 2002 is equal to GDP of 1948 e to the power of 54R is equal to 3.853, which is equal to e to the power of 54R. Taking natural logs of both sides, one obtains ln of 3.853 is equal to 54R. 1.348852 is equal to 54R. R is equal to 0.02479 less than 2.5. As expected, in case of continuous growth formula, we can get a lower annual growth rate, since continuously growing variables grow to a higher level during the same period of time compared to their discrete analogous if the nominal growth rate is the same. International GDP comparison. We can measure national productive activities so that the numbers can be compared across nations. This is to compare international GDP of one country with another country. When a GDP numbers for various countries are compared, the same currency unit must be used to compare one country's GDP with another country's GDP. We have to convert, first of all, currency in one unit. For example, from euro to dollar to know the GDP of American comparing with other Euro countries. There are two ways of converting from national currencies to common currencies such as USA dollar. In one method, market exchange rate method. In another, we can use purchasing power parity methods. Market exchange rate methods. How we can convert using market exchange rates. For example, step 1, look up, for example, for Ethiopians, GDP in Ethiopia's currency or birr. Step 2, look up how many USA dollars one Ethiopian birr is worth, or USA dollar one China's yen is worth, or Arab Emirates dinars worth, or Kenya's shilling worth, comparing with USA dollar. Multiply the numbers in step 1 and step 2 in such a way that Ethiopian GDP in USA dollar is equal to Ethiopia's GDP in birr times $1 over 38.65 birr. This is before 3 years or 2 years value. It's not a current value. Currently, it is around 156, $1 over 136 Ethiopian birr. This gives you Ethiopia's GDP in USA dollar. So now Ethiopian GDP in birr times $1 over 338.65 birr. Now we can remove birr with birr and it left with only dollar, so that we can compare or we can express Ethiopian GDP in dollar in this way. If the GDP of the two countries are both expressed in USA dollar, the same dollar, they can be compared head to head or in the same currency. The second method is purchasing power parity method. Purchasing power parity is a popular metric used by Microeconomic analysts that compare different countries' currency through basket of goods approach. Purchasing power parity allows for economists to compare economic productivities and the standard of living between a country. The real GDP adjusts nominal gross domestic product for inflation. However, some accounting goes even further, adjusting GDP for purchasing power parity values. This adjustment attempts or try to convert nominal GDP into a number more easily comparable between the countries with different currencies. To better understand how GDP paired with purchasing power parity works, suppose it costs $10 to buy a good in USA and the same good costs €8 to buy and in German. The product is the same, but the same product is $10 in USA, €8 in German. To make comparison, we cannot compare in such like ways, so we have to convert in the same dollars or in the same currency. To make comparison, we must first convert euros to USA dollar to make it the same units. If the exchange rate was such that the good in German costs $15, the purchasing power parity therefore be 15 divided by 10, that is 1.5. This is purchasing power parities. In other words, for every $1 spent on the shirts in USA, it takes $1.5 to obtain the same shirt in German, buying it with the euros. So this is a purchasing power parities method. The shirt is the same, but because of a currency difference, there is a difference in purchasing power parities. What is drawback of purchasing power parity? The following factors to explain why the purchasing power parity theory is not a good reflection of reality are transporting costs, tax difference, governmental intervention, non-trade service, and the market competition. Purchasing power parity do not consider or do not take into account such events or such activities such as transportation cost, tax differences, governmental intervention, non-trade service, and the market competition is not considered under purchasing power parity. Because of this, they have problem or drawback. Is GDP a good measure of economic well-being? No, but it is the best one number measure we have. It is not a good measure, but since we have no another alternative, since we have no another real one than it, we can take it as best. There are a lot that is missing in GDP. For instance, work done in home worker, for example. Housemaid work is not considered. Voluntary work is not considered in GDP calculation. Illegal work is not calculated in GDP or not considered. Leisure time, it is not considered. Environmental pollution or environmental problems not considered or not counted in GDP. Disaster is not considered or counted in GDP. And it is so that GDP has not or is not a good measure of economic well-being because it's a loss, such activity. It does not count voluntary work, ignore environmental damage, consumer surplus, does other many things. In consumer surplus, there are free digital technologies such as free app, Google, Google Maps, Wikipedia, OpenOffice, YouTube, Telegram, TikTok, and the freely available education. This is not taken into account. Therefore, none of this adds to a GDP, and so GDP is not good measure of economic well-being in a country. With this, we come to the end of our chapter 1. As we have seen before, because of every transaction has buyer and the seller, the total expenditure in the economy must equal the total income in economy. This is when we measure GDP by using different approach, that is income approach and expenditure approach, but the value is the same. GDP is a good measure of economic well-being because people prefer higher to lower income. It is not perfect measures of well-being because something such as leisure time and a clean environment, environmental pollution and such are not measured by GDP. So it is not uh, perfect measures of well-being. It measures an economist's total expenditure on newly produced goods and the service and the total income earned from the production of these goods and the service. It is the market value of all final goods and the service produced within a country in a given period of time. It is the best single measure of the economic well-being of the society because there is no another alternative that is more than GDP. GDP per person tells us the income and expenditure of the average persons in the economy. GDP is divided among 4 components of expenditure when we use expenditure approach. That is consumption expenditure or expenditure for consumption, investment expenditure, investment expenditure or uh, money we expend to invest, government purchase expenditures when government purchase something, and the net exports expenditure or the difference between export minus imports. Nominal GDP uses a current price to value the economy's production or the final good is calculated based on current market price under nominal GDP. Real GDP uses a constant base year price to value the economy's production of goods and service. As we have discussed in the previous, our chapter 1 or our video 1, real GDP is calculated by using base year price, a year that we select as a base year. As we said, base year is calculated or selected based on different criteria such as when there is economic stability, price stabilities, when there is no war, when there is no economic recession, when there is no economic boom, totally when there is economic equilibrium that's selected for base years. Depending on that one, we can measure real GDP by using that price. And GDP deflator is calculated from the ratio of nominal GDP to real GDP, which measures the level of price in the economy. We have discussed that GDP deflator is calculated by using real GDP divided by nominal GDP divided by real GDP. We know that GDP per capita is equal to GDP over population. That is GDP per capita means this one, or income for population, or total income for total population. The other one is growth rate of GDP is growth rate of the population plus growth rate of the GDP. We plus growth rate of the GDP with population. GDP per capita. This implies for people's income on average to increase over the time. GDP growth rate exceeds population growth rates. That is, purchasing power parity of GDP per capita of Ethiopia, for example, is equal to the summation of I to N is equal to 1 PI in USA dollar times quantity of I in Ethiopian over total population in Ethiopia. That is, purchasing power parity GDP per capita of Ethiopians. With this, we come to the end of chapter 1. I thank you very much for your attention and also for your comments. If you liked my work, please subscribe more. Don't forget to like, share in the comments. My email is bolayele@yahoo.com. If there is a question, suggestion, you are welcome. As we said, this economics is somewhat advanced economics. I will come with principle of economics as a whole with another video, but we continue with this to chapter 2. This is advanced economics. That is for experts, for MSc students, for professionals, and the BA2. For other non-economist students or person, I will come with principle of economics with another video. Have a nice time.